All right, in this example, we're going to be looking at solving a trig equation using a calculator. So in this equation, we have sine theta equals negative 0.2, and the instructions do specify that we're going to solve on the interval from 0 to 2 pi. So any angle between 0 and 2 pi that satisfies the equation, we're going to have to give as a solution. So the first thing that we notice is that the sine of theta is negative. Remember from the unit circle that the sine is y. And if we look at the coordinate system, we know that in the unit circle, we're going to have a y coordinate in the third quadrant and the fourth quadrant. So what that means is there's going to be an angle from here to here, and then an angle from here to here. There's going to actually be two angles that give us a negative y coordinate, so we're actually going to have to come up with two solutions. All right, so let's find the first solution. Moving the sine over, that's going to give me inverse sine of negative 0.2. And if I go to my calculator, inverse sine of negative 0.2 gives me, well, negative 0.2, and that is in radians, so that's a radian angle. And so I know that inverse sine is programmed to give me angles from negative pi over 2 to pi over 2. Remember, that's the restriction for the inverse sine. It only gives angles from negative pi over 2 to pi over 2. Okay, so what does that tell me? That tells me that the angle from here to here is negative 0.2 radians, okay? So then how do I get the positive angles, knowing that this is negative 0.2? Okay, well, first of all, if this negative angle is negative 0.2, then the angle in this area also has to be 0.2. So we can see that this first angle is going to be 0.2 past pi. So again, we're going to go to the calculator, and we're going to go pi plus 0.2. And so the first angle that I need is 3.3, let's call it 3.34 rounded. So the first angle, the first solution is going to be theta equals 3.34 rounded. And we know that there is another angle in the fourth quadrant, and we know that this angle is going to be 0.2 or 0.2 away from 2 pi. So if I take 2 pi and subtract 0.2, I'm going to get this other angle. Okay, so here we go, back to the calculator. At this point, we need to do 2 pi minus 0.2. And that's going to give me 6.08 rounded. So the other angle that I'm going to need is 6.08. And those are my two angles in radians that satisfy this equation. Now, I'm going to prove it. So what we're going to do is we're going to check this solution using DESMOS. So if we go here and we open DESMOS, what I can do is I can graph the equation y equals, let's see, what was the trig function? Sine theta or in this case y equals sine x. And since we're looking at values that are between 0 and 2 pi, I'm going to restrict the domain to only show those values. So we're going to say 0 less than or equal to x less than 2 pi. And so that gives us a graph of the sine wave showing only values from 0 to 2 pi. And now what we want to do in this second equation is we want to say y equals whatever the sine theta should be equal to. And that's negative 0.2. So y equals negative 0.2. Oh, and look at that. Do you see there's two intersections? Right here and right here. So those values, those radian angles where sine theta is equal to negative 0.2 is 3.34 and 6.08, and that is exactly what we got doing it by hand.